Hi everyone, welcome back. I'm so glad to be here talking to you today, and this is my professor, Karthish. He currently teaches me in Chemie 103C here, which is a transport class. But I recently found out he's actually a Science Olympiad alumnus too, so we figured we had to speak to him. So Karthish, thanks so much for talking to us today. Can you tell us a bit about what you do here?
Yeah, absolutely. So I started here at Caltech as a faculty member in chemistry and chemical engineering just last year. I was a faculty member at MIT for 5 years before that, but got very excited about getting to be part of this community here at Caltech. We're a really small group of researchers who work together in a very collaborative and interdisciplinary fashion to make progress on what we think are some of the toughest problems of our generation. We figure out the science first, and we hope that science then creates a pathway towards having impact on the world. My own research group works specifically on taking renewable electricity and using that to convert air and water into useful molecules. So imagine if we could make the fabrics of our shirt or even components of the chair that we're sitting in using just air, water, and sunlight instead of using petroleum, which is often the feedstock that goes into making the physical world.
Oh, I see. Can you tell us a little bit more about that process of how you get things from there into actual products we can use, and what was the thought process that went into it?
Definitely, yeah. So I think a lot of what this involves is designing catalysts. Catalysts are these entities that are able to grab onto molecules, bind them to their surface, and then rearrange the chemical bonds that exist in those molecules. So we start with CO2, nitrogen, and water. We take those design catalysts that will bind them and scramble the bonds to then make molecules we care about. These are molecules like ammonia, or making an amino acid, or making ethylene to make plastics, all from just CO2, nitrogen, and water. Really, our source of inspiration, this is nature. Nature actually already does this. We are not able to do this abiotically without nature. So we're trying to find new pathways to do this without a living system, and to be able to power it all using electricity, since we have this new opportunity where renewable power is so much cheaper than it used to be. And that's really what we're driving forward in our lab, that science and making catalysts that manufacture the physical world sustainably.
Got it. And it's really fitting that we're in the Resnick Institute of Sustainability. It's over there. Changing gears a little bit, I heard you were a Science Olympiad competitor. Tell us about your competition days.
I was. Actually, it was my very first opportunity to go from very traditional textbook learning in a classroom where a teacher told me what I was going to learn in a given day, and I'd go home and do the problem set and come back and I'd take an exam. I'd grown very used to that ritual, and I really needed something to help make me feel more excited about going to school. And I remember finding Science Olympiad, and I remember being told that I was going to be on this event called Dynamic Planet, and I had to go and learn about this broad field that was huge. There were so many different aspects and topics that went into Dynamic Planet. I no longer had someone telling me what I had to know. I remember going to the library and taking 20 books off the shelf and struggling to carry these home, and then starting to page through these and deciding how I was going to study that material. And the reason that's important is that to me represents open-ended inquiry. It's what it means to learn by yourself, self-directed learning. And that for me has been now the majority of what I do on a given day as a faculty member or working with my students. It's teaching them how to think and how to learn something when someone isn't telling you what to learn, right? And so Science Olympiad was sort of my first journey into open learning, and so it was a very special opportunity for me for that reason.
Got it. So hopefully this will get released a few days before the tournament. Do you have any advice for competitors who are maybe watching this right now?
Yeah, so there was this event called Robo Billiards that I remember competing in. It was by far the event that I put the most time into. I would stay up late at night building this robot. Weekends, I worked around the clock trying to build this thing. And the real challenge for me was that I built something that I thought was functional, that I thought should work, that I thought should be competitive, that I thought should win. And I went into this competition. I remember setting it down on this table, competition day. It was the state tournament in Texas. And we start the event, and we start moving this robot, and boom, one of the contacts snaps off. And when the contact snapped off, that was it. That wasn't something that I could have planned for or that I could have anticipated. It just happened. And that for me was one of the biggest lessons that I learned in this, is that you do something like this that's risky. You do something like this that involves something that could fail, and it could fail for reasons that are outside your control. And so we ended up ranking at the very bottom. We were the last team out of all that competed, even though this thing I poured all my time into. And I remember, like, for a long time after that, it bothered me. It bothered me that I had failed at this, that I had done the poorest of any team that had entered this competition, despite putting so much time and love into this. And I had to learn that I couldn't just look for this external validation. I wanted that external validation so badly going into the competition. But I had to learn that a lot of this wasn't about what someone else thought about me. It was what I am learning in this process. It was the love that I had shown to this subject, how I had grown as a person through this, and to place value on that, and to know my own true intrinsic enthusiasm and excitement for something, that was enough. That is all that I needed from this. Now, I still seek internal validation sometimes. I'm not free of this force, but learning my own internal compass and knowing what I do in my life because I need it and I want it has been so important for me professionally and personally. And I think Science Olympiad was sort of one of those first times where I had to learn that for myself.
I see. All right, well, thanks so much. That was really inspiring advice you gave. And I know for me personally, Karthish is one of the most inspiring profs that I've had here. So I really want to thank you for spending the time to talk with us today, and hope, the viewers can learn something more about Caltech and about you.
Awesome, and I just want to thank Albert, and obviously there's an amazing team of people here at Caltech that are throwing this competition, putting in countless hours and sleepless nights to make this event what it is. I just want to thank them as well for making this opportunity possible for everyone coming in.
Thank you so much, Karthish. All right, we'll see you in the next episode. Bye.